Okay, let's evaluate this integral, and we're going to do this manually using the limit definition of the integral. And so first we want to make a Riemann sum as a function of n, and then we're going to take the limit as n goes to infinity of that Riemann sum. But which Riemann sum do we do? Do we do a left endpoint, right endpoint, midpoint, some mixture? Well, because when you take the limit as n goes to infinity of the Riemann sum, they all converge to the same value, which is the value of the integral. We can choose whatever Riemann sum we want. So we might as well choose the one that's the simplest mathematically, and that's the right endpoint method. So first we want to determine R sub n. Okay? And this R sub n is the sum from I is equal to 1 to n of the function evaluated at x sub I, and that's why the right endpoint method is simple, because it's just x sub I. You don't have to do anything other than just strictly x sub I. This would be more complicated with like the left endpoint or the midpoint method. Delta x. Okay? So what is f of x? F of x is x squared minus 4x plus 2. Okay, what else? Well, we have b is 4, a is 1, and then delta x is b minus a over n, which is 3 over n. All right? x0 is a, x1 is a plus 1 times delta x, x2 is a plus 2 times delta x, etc. All the way to xn is b. Okay, and so if we look at the pattern here, x sub I is 1 plus 3i divided by n. And so remember, the way the Riemann sum works, this is for any method you're using, left endpoint, right endpoint, whatever, when I is equal to 1, then you're talking about the first rectangle, the first interval. When I is equal to 2, you're talking about the second interval. That's how it works in the Riemann sum. And when it comes to the actual setup, again, this is independent of the method you're using, left, right, middle, whatever. X sub I is the right endpoint. It's always the right endpoint, x sub I, of each interval. And so all you do is just f of xi for the height of the rectangle. If we were doing the left endpoint, it wouldn't be f of xi, it would be f of xi minus 1. So it's still, so if it was the left endpoint, it's still when I is equal to 1, you're dealing with the first rectangle. When I is equal to 2, you're dealing with the fourth or when I is equal to 4, you're dealing with the fourth rectangle. But what's evaluated is so if you're at I is equal to 4, okay, you're doing the left endpoint method. So you do f of xi minus 1. The height of the rectangle is x sub 3 for the fourth rectangle, because that's the left endpoint of the fourth rectangle is x sub 3. You see? And like for the midpoint, you would have to do, it would be x sub I minus 1 plus x sub I divided by 2. That's what would be input inside of the function. You would evaluate the function at x sub I minus 1 plus x sub I, all that divided by 2. So that when you're at the I is equal to 4, the fourth interval, what you're putting into the function is the midpoint between the third and the fourth, the midpoint between x is equal to 3 and 4. Right, exactly. X sub I minus 1 plus x sub I divided by 2. So that's the idea. And so you can see it's easiest with the right endpoint, it's just x sub I. Okay? So next let's evaluate f of x sub I, because we're going to need that. So this is f of 1 plus, okay, so this is Okay. There we go. So let's simplify this. If we expand this, we get 1 plus 3i over n plus 3i over n is 6i over n plus 9i squared over n squared minus 4 minus 3i over n plus 2. Okay, so we've got 1 minus 4 is minus 3 plus 2, so minus 1 plus 6i over n minus 3i over n, and then plus 9i squared divided by n squared. Okay, so now what is f of xi times delta x? Okay, well, we'll put it in. Let's do 9i squared over n squared plus 3i over n minus 1 times delta x is 3 over n. Okay, so this is 27i squared over n cubed plus 9i over n squared minus 3 over n. Okay, so now let's put this f of xi delta x into the Riemann sum. Okay, so now this is where the summation properties come into play. You have to know your summation properties, how to work with summations and summation properties to simplify this. So we can separate this into 3 separate sums. Okay, so now we can factor out into the front of the summation anything that's not a function of I. So we could do this. We could take out 27 over n cubed out front of the summation. We could take here, we could take out 9 over n squared. And then here we could take out the 3 over n. Okay, now the textbook gives us, like, the sum from I is equal to 1 to n of I squared. That the textbook gives us this. This is n times n plus 1 times 2n plus 1 divided by 6. Okay. From the sum from I is equal to 1 to n of just I is n times n plus 1 divided by 2. Okay, now the sum from I is equal to 1 to n of just 1 is n. Okay, so now let's simplify. These n's cancel. We're left with just 1 n there, and then so 27 divided by 3 is 9. 6 divided by 3 is 2. Okay. You got 9. Okay. Okay. Let's combine these. So the common denominator would be 2n squared. So we can go ahead and start expanding this. So 9 times 2n squared plus n plus 2n plus 1 Okay. Now here we need to multiply an n, so this would be 9n times n plus 1. And then this would be 6n squared. And so then all of this would be over 2n squared. Okay, so we've got 18n squared plus 27n plus 9 plus 9n squared plus 9 minus 6n squared all over 2n squared. Well, this is 9n here. Okay, so 9 minus 6 is 3. 18 plus 3 is 21. 27n plus 9n is 36n plus 9. Okay, I made a mistake here. This should be, I didn't multiply the 4 here, so this should be 12 minus 12i over n. Okay, so you've got, still have minus 1, and then 6i over n minus 12i over n, so this should be minus 6 I over n. And then 9i squared over n squared is correct. Okay, so we've got, this would be minus 6 I over n. And then that would be 27. Okay, 6 times 3 is, this would be minus 18 I over n squared. Okay, so minus 18. All right, here's minus 18. Okay, minus 18. And then all right. So this is minus 18. And so, okay. And so then that would be minus 18n. So you've got 18n squared plus 27n plus 9, and then minus 18n squared minus 18n minus 6n squared minus 18n squared minus 18n minus 6n squared. So here it is, so 18n squared minus 18n squared goes to 0. You're left with minus 6n squared. Okay. Then 27n minus 18n is positive 9n, and then plus 9. Okay, so we can divide the numerator and the denominator by 2, and you're left with, or no, can't do that. So yeah, that's R sub n right there. Okay, so there we go. That's R sub n. So to evaluate this integral, what do? We take the limit as n approaches infinity of R sub n. Well, how do you evaluate this limit? This is a rational expression. So and the numerator and denominator have the same order. So in that case, it's going to be just the order of the coefficient. You just look at the coefficients of the highest order term. So it's going to be minus 6 divided by 2. This is going to be minus 3. So this is minus 3. That's this limit. The limit as n approaches infinity of this is minus 3. And so that's the integral.